So, good morning, class. So, sorry I cannot be in the classroom with you this morning because my flight got delayed, and so if you are watching the video, I'm still traveling on the plane, and so we have to put the videos up for the first day of class. Sorry for the inconvenience, and please follow the instructions on Canvas to register my math lab through BBDU. Okay, so this is a very important first step. You do not need to pay for the my math lab. You only need to register from the class. Okay, the details is provided on the syllabus. And again, so this course is supported by NSF grant I use, and so we will collect some like surveys and pre-test for the course, and there is a survey link provided on the canvas. Please and take the survey, and I will give you extra credits on the midterm if you do it during the first week. Okay, and so for today, I will go through the basic definitions in chapter 1. Chapter 1 does not involve too much calculations, so it's only basic definitions. So I will keep it on the video, and so that we can have more time to focus on the complicated calculations later on. Okay, and so now I will start record my chapter 1. Okay, so this course is called Biostatistics, and in chapter 1 we will just give the basic definitions, introduction to statistics. We will learn what is the critical thinking and statistics, basic definition of statistics and data and all the basic important concept related with statistics. The second one is the types of data that we are going to tackle this semester, and then the third section is the data collection method. Okay, so how could we collect the sample data? Okay, and as most of you guys are biology majors, so this course will be a super important course for you guys. Okay, so 1.1, so some basic definitions. So what are data? Yeah, so what is data? Instead, data is important. Data is plural. Yeah, so the term is a single word. But when we use data, the first thing is English. Yeah, data are, do not use data is. Yeah, so the data is a collection of observations. All the observations such as measurement or survey responses or anything that you wanted to collect. Yeah, and the statistics is a science. So this is a science course, applying studies and experiments, obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data. So we always statistics course focus on the data. We want to do everything with the data and then draw some conclusion from this data and tell the other people. Okay, and so the population of the data is, so population, this definition, we always learned the population with what sample. Population is what is a complete collection of the data. Yeah, so it's the entire data set. And the sample is a subset of the data that collected from the population. So population include everything. Like if you wanted to do something with the entire college students of the United States, then that could be a population. What will be a sample? If we wanted to do something with Fisk students, that will be a sample. This is what we do for the NSF I use project. And so we wanted to say, what should we do to help all the African American students or college students in the United States? So what should we do? We wanted to do something with our Fisk students, which most of you guys are African American students, yeah. And then we wanted to see whether it works for Fisk. This is called what we wanted to use a sample and to get the result for the population. Okay, and the census is the collection of data from every member of the population. Means census means all the data collected from the entire population. And the variable is a characteristics can take on different values for different persons. Okay, and so we also have what statistical analysis is need variability, and there is what nothing to study. So we all know this thing, yeah. Okay, and so the examples, of these things will be and the concentration of a substance, yeah, and pH values from the rivers, birth weight of babies, and all these kind of different like things that we can talk about it. Okay. So and the next picture is the outline of the entire semester. Yeah, so we wanted to prepare the data collection. So chapter 1 is to tell you the basic definitions, like what means data, what are the source of the data, what is the goal of the study, and all these kind of things. Yeah, so if you have a study and you want to define what is the goal of your study, and what kind of data do you want to collect, where do you want to collect the data, yeah. And so this is basically the chapter 1 we will give you the basic definitions to see what is going on. And then for chapter 2 we wanted you to learn the concept, how could you explore the data, with the tables and the graphs. And you guys know, like, different tables like paragraph, bar graph, and all these different graphs, all these different tables, yeah. And then, the chapter 3, 4 is explore the data and, distribution, are there any missing data, all these kind of things. You guys learned, the basic definitions, like what means probability and all these basic, things like how could we describe the data, like what means mean, what means the standard deviation. And then chapter 5, 6, 7 is the discrete distributions, normal distributions, estimate the parameters and all these things. Then chapter 8, 9, 10, and 12 is the hypothesis testing, and how could you make claim that you have a very good result, or claim something is effective, yeah. Okay, so this is the outline of this course. So more definitions. A voluntary response sample is one which the respondents themselves decide whether to be included. So what would be a good example for a voluntary response sample? Like what? Your survey. Okay, so you decide whether you wanted it to be included or whether you wanted to complete it. But I strongly encourage you guys to complete the survey, because I really need the data to help more students, especially more Fisk students in the future. So please help us. Although it is a voluntary response sample, but I strongly encourage you guys to do it. And I also will give you extra credits for you guys to complete during the first week the class, and and the extra credit will be provided on the midterm. Okay, and the statistical significance is achieved in a study when we get a result that is very unlikely to occur by chance, generally 5%. So statistically significant result. Yeah, so we always say significantly increase, significantly decrease. Yeah. What does this mean? How could we use statistical significance to describe the results? Yeah, so I can give you an example. We all know that we have AESP tutoring on campus. So if you go to tutoring on campus 5 hours per week, and your final course grade is increased by 10 points. How could you make this event to be statistically significant? Yeah, so if 30 students, one is too random, yeah, and all 30 students final exam is increased by at least 10 points. How could you make this event statistically significant? What should you do? How could you claim this is a thing? What should you say? What are you comparing? Yeah, so you wanted to say, when we get a result that is very unlikely to occur by chance. By chance means if students, yeah, so if all students do not go to tutoring, the chance to increase their scores by 10%, 10 points is very likely or unlikely? Very unlikely to occur. Yeah, so if you can choose any number below the 5%, it will work. Like is we make it more maybe 0.1%. Yeah, so if you do not go to tutoring, 10 points increase 0.1%. It's almost 0%, or any number less than or any number less than 5%. You can claim that this is statistically significant. Okay, and so these are the examples, yeah, and so so in a USA Today poll, and 7 of them said that they prefer drinking bottled water instead of tap water. The sample is voluntary because it's internet survey, yeah, it's internet survey, so it's your choice whether you want to respond or not. And this is another example for the MCAT that is commonly used, commonly taken by you guys. Yeah, so a lot of you guys want to go to medical school. Yeah, so if we have 16 students, and if they take this preparation course, and then their average score rises from 25 to 30, there is an increase. But there is only 0.3% chance of getting these results by chance. Then, what could you conclude? This is statistically significant, yeah, according to our definition. And we can claim this is statistically significant result. This means, what could we conclude? This preparation course is very effective. Yeah, so effective is the word used to be to describe whether it's statistical significance. Okay, and so you guys are mostly biology majors. When you analyze the data, what are the potential pitfalls? Misleading conclusions. Yeah, so correlation do not imply causation. This is one of the very common one. A lot of people who smoke cigarette, and then they tend to have a higher pulse rate, but it doesn't mean that when you smoke a cigarette, it will cause a pulse rate increase, according to the science people. Okay, and the sample data. So it doesn't mean that there is a correlation. Like if this increase and then the other thing increase, correlation does not really give us the region. Okay, so when you make the conclusion, you need to be very careful. And the sample data reported instead of measured, yeah, like people's weight or people's height, yeah. So if you ask me my height on the internet, I will tell you 6'3", and you will know how tall I am when you guys come to the class. Okay. And the second one is loaded questions and order of questions. Yeah, so when you design some interview questions or a survey question, the order of the questions is very important to get the responses. If you ask the question in the different order, maybe nobody wanted to answer you because you feel so bored or annoyed. Yeah, non-response, percentage. Yeah, so means how many percent. Yeah, so the next thing we wanted to say is a very important definition is called types of data. So we wanted to introduce two things. And do you guys remember population is the entire group? Yeah, so the entire set. A sample is a subset of population. Yeah, and we also use two different words to describe the numerical measurement, describing some characteristic of the population and the sample. So we use what parameter for population, statistic for what sample. Yeah, so we can look at the picture below. So population we use parameter, and the sample we use what statistics. And so like the example that I gave you at the beginning of the class, the sample can if we wanted to say if we find an intervention that works for Fisk students, then we can claim it might work for all the African American students in the United States, because Fisk is such a prestigious university, and we have such a high population of African American students on campus. Yeah, and then what means the population to predict sample. Yeah, so like if we wanted to say like African American, all the entire United States African American students, what should we say? The family income is 25. Is like maybe 250K per year. Yeah, and then and Fisk students 90% is what African American students. Yeah, then what could you predict for the Fisk student, the family income of Fisk students? You can almost say safely to say maybe 250K, because this is the entire population, and Fisk is a random sample. Yeah, so sometimes sometimes it is safe, but sometimes it's not. Yeah, so depending on what other conditions, whether it's random or not random, or Fisk has some special conditions for recruiting people, or all the other conditions. Okay, so now let's look at the example on the top. Yeah, so there are this many high school students in the United States. What is this number? That is what population. So this is population. Yeah, so this is the population, and and this number is a parameter. No? Yeah, so because these are all high school students in the United States. Yeah, in a study, 8505 high school students 6 years of age or older, 805 over 5. That is what a subset of this population. So this is what a statistic for a sample. Yeah. So we choose 8505 students from there, and 44.5 of them said that they are texting while driving. So this is a statistic. Statistic will be what numerical measurement describing some characteristics of a sample. You with me? So this is 44.5% that were that reported that to be what to be driving while texting while driving. Okay, so this is this, yeah. And if we wanted to claim, how could we make this 44.5% to become a parameter? Yeah, so if we collect all the data from all these many students, and then this can be also a parameter too. Okay, it can be a parameter too. Okay, and so this is this, and like this is a population worth what samples, and so basically there are a bunch of them, and you only select a subset, and x bar and mu, these are the sample mean and the population mean. Mean means what average, yeah. And some basic concepts of the data means quantitative. There are several definitions, yeah. So there are quantitative data and categorical data, discrete data and continuous data. The first two is like a pair. The second two is a pair, yeah. Quantitative data are numerical data. Yeah, so like the age of the student, or the height of the students. Like categorical data are qualitative data or attribute data, consists of the names or labels. Yeah, so it's not numbers, or okay. So you like the genders, the eye colors, and all these kind of things are called categorical data. And discrete data, when values are quantitative and the number of values is finite or countable. So what does this mean? Discrete data, like if you wanted to say, like how many students get A's in the class, we can only see 5 or 2 or 3. Could we ever see 3.5 student get, A's? No, yeah. So, it's only, a integer number, yeah. So this is what accountable means, what it can be used in integers to count, okay. Or like the example that it gave here, the number of tosses of corn, or the number of births in Houston before getting a male. The continuous data and discrete data are very interesting to differentiate, okay. It will be what result from infinite many possible quantitative values, yeah. So the collection values is not countable. This one is, from definition, it's hard to see. Continuous data actually, is that you cannot give the exact value for this data. What does this mean? So the height of Qingxia Li, which is 6'3", yeah. Is this, could I say this is a perfect 6'3"? Yes or no? How could you differentiate 6 6.29996 feet at 2.2999 feet inches, or at 6 feet at 3 inches. What is the difference? How could you tell the difference? And it's very hard, yeah. And I can tell you, it's very hard. You just keep continue 2.999999 forever. Are you guys with me? How could you tell the difference? Yeah. So you can only see he is 6'3", and which is, or it's a it's a value that is almost this value, but it's not accurate. This kind of data we call it what? Continuous, because it is impossible to find the exact value of the height. Yeah, so these are called what? Continuous data. Okay, and then we also introduce what are the levels of measurement, and I believe that you guys all heard this before. The nominal level and ordinal level, interval, and the ratio level. Nominal level like yes or no, or like eye colors, basically are a lot of them are categorical, yeah. And ordinal level, it can be what? Arranged in some order, like course grades A, B, C, D. Yeah, but when you subtract A minus B, does not mean anything. Are you with me? So it's not a numerical value, numerical grade, A, B, C, D. But if you A minus B, does it mean something? Not really. Yeah. So ranks of colleges in the U.S. News and World Report. Yeah, we can rank them in some order. Number 1 Harvard, number 2 Princeton. But 1 minus 2 or 2 minus 1, what does this mean? Yeah, so the data values cannot be really determinate. Yeah, and the data at the interval level can be arranged in order, and the difference between what data values can be found and are meaningful. Like, but what is the most important thing? They do not have a natural zero. Okay, so what does not have a natural zero? Temperature. Yeah, so I want to remind you, temperature does not have a natural zero, because if this is 0 degree, does this mean no temperature? It also have some temperature. Yeah, it's just called 0 degrees. So 0 is, we are using 0 degrees is just for convenience, like the years. Yeah, so we are 2025 this year, but 2026 this year. Yeah, so what does this mean? Are you guys with me? So what will be year 0? This means there's nothing before year 0? Oh, no. So we just choose, the year 0 from a certain time or from a certain event to define. Okay, at the ratio level, you do have the 0. The 0 does make a difference. Yeah, so like the height, the weight, the class time, the duration of the class time, they are all what, ratio level. Okay, and the next definition is called what? Big data and missing data. So what means big data? Big data means you are involved with a large set of data that is very, very complex. Yeah, so it's a very popular area, and we all know that it needs special things to handle all this big data. And data science is a very popular major on campus now. A lot of people wanted to have data science as a minor, like a lot of biology students, history students, business students want to have a data science minor. Okay, and the next thing is a data value is missing completely at random. and not at random, and collecting the missing data. Yeah, so I give you 3 examples. So if a survey question asks each respondent to enter his or her annual income, if I only make less than $10,000 per year, I will not report. If I do not want to lie, I will not write down anything because I'm so embarrassed. I do not want other people to know that I'm so poor. Are you guys with me? So this is called data value missing not at random, because these values are missing because of some specific regions. Yeah, and like the next example is like, if I'm doing the survey and my roommate just hit me from the back, then or talk with me and interrupted me, and then I forgot some question, then this is called what? Missing completely at random. Yeah, and so for the correction of the missing data, sometimes you can use average, or you can randomly generate some values, or sometimes you should what? Delete this survey if you have a lot of responses. Okay, so these are the typical ways to handle this. And the last thing is collecting the sample data. So we will basically talk about 2 things: experiment and observation study. And so you guys are most likely, biology majors, so you guys all know experiments. Yeah, so for, it's like, biology major, you always have a treatment, group and a control group, yeah. And you wanted to, like give some drugs or give some, experiment on certain group. And then you use this group, like do not do anything, and then you compare the results. Yeah, so this is the typical things that, you guys do. Yeah, but like how could you design your experiment? Are you guys with me? So that will be a very important thing that you wanted to learn from statistics. Yeah, so and this is why we call it a sampling is so important. So when you design experiment, yeah, so how could you select your control group? How could you select your experiment group? That's very, very important. Yeah, so otherwise, a lot of people were like complain about your sampling method. Yeah, so I can give you some examples. Like if somebody designed a experiment, treatment group with all women, and a placebo group with all men, yeah, could you make a conclusion for whether the drug works? We can't. Yeah, so because we do not know whether this works because it's a woman or it's because of the drug. Are you guys with me? Yeah, so this is will be like a different story. Yeah, so so that will be so hard to say. And sometimes we wanted to say, oh, how about we always use completely randomized the experimental design. This method sometimes is good, but sometimes it's tricky. So if you randomly select people, but when you randomly select, what happened? All the people that you select are happened to be all women. What happened? What do you do? Yeah, so that will be maybe sometimes completely randomized experiment design may not be a good one too. Okay, so so this is why some people, in order to especially for test drugs or test something, they not totally randomly select. They will select some women and what some men to make a group. Yeah, so like okay, so maybe we will select 30 women, but from these 300 women we will randomly select, and then we also select 30 men, but from all these men we randomly select, so that we will form a group. This might be more useful to get the meaningful results. Okay, and the other thing is matched pair design, like pre and post. Yeah, so that is like our survey. We will give you a survey at the beginning of the course and also at the end of the course. We wanted to measure what is the difference for each one of you from the beginning and the end of the course. Okay, and so for the sampling, and we have several sampling methods that we wanted to introduce. A simple random sample means totally random, just select any value that by chance. And in a systematic sampling, like, okay, so just look at the picture here. This will be a very good example. If we wanted to choose every third car, or if we wanted to ask you line up in front of the class, I wanted to pick every other student. Yeah, so this will be a systematic sampling. Stratified sampling is like we want that is the woman and the main thing. Yeah, so that is the thing that I discussed. We wanted 3 women and 3 men randomly from. We wanted some women and men because we wanted to have result from both genders. Yeah, cluster sampling is used a lot in computer science. Yeah, so like what does this mean? So if we wanted to get the results from this community, like Davidson community, what happened? Like Antioch, what happened? Yeah, and Franklin, Brentwood, what happens? Are you with me? So that means from this community, what kind of results could you have? What kind of characteristics could you use to describe the population here? Okay, and the sampling errors, we have sampling errors and non-sampling errors. Okay, so the sampling errors come from the method itself. Yeah, so if you use a completely random sample and it happens to be all women are selected, that is a sampling error, because you wanted all random and this is the chance. Yeah, and the non-sampling error is the result of a human error. Yeah, so like if you input the wrong data, and computing errors and all these kind of things. Yeah, a non-random sample error is using a method that is not random, such as using a convenience sample or voluntary response sample. Yeah, so if I wanted to collect some data from the student, if I wanted to interview some students, and then I will only interview the student who came to the class. This is a convenience sample, but this may give you a non-random sampling error. If you wanted to get the experience of all the students in your class, and if you only choose the student who come to the class, this has already been a biased group. Are you with me? Maybe the student who always hated the class never came to the class. Are you with me? So then so it depends on the all these kind of things you will know. Okay, so that's for this chapter, just read the book and try to learn all these basic definitions. Okay, and thank you, and I will see you on Wednesday. Please do not